Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today's episode is brought to you by our new book. If you're looking for something to add to your wish list and you like our show, then may I suggest our book, 50 Dinosaur Tales, which you can find all over the internet. And if you don't want to search for it, you can go to bit.ly/50 Dinosaur Tales. 50 is the number 50, and Tales is Tales, because it's got 50 stories about dinosaurs in it. This week in our 260th episode, we have a new dinosaur from Australia, because of course we need to cover that since we were just there. We also have some new dinosaur tracks from Alaska, and we have a T-Rex tooth replacement story. We also have an interview with Matthew Mossbrucker and dinosaur of the day, Leptoceratops. But before we get into all of that, we want to thank some of our patrons who are the main reason that this podcast keeps going. And as we're recording this, it's actually Patron Appreciation Day.
Although you'll hear this a little late.
Yeah, one day later, because we're recording this episode a lot closer to the release than we usually do. But this week, we'd specifically like to thank Lucas and Eli, Wyatt, the Georges family, John Heck, Ranger Chris from Dino for Hire, Ray, Oliver E., Andrew and Helena Webb, Callum, Ricky, William, Red Sox Rex, Wouter, Moss Utah Raptor, Velociraptor, Switchbreed, Goji, and Australovenator. And Australovenator just joined.
Yeah, thank you so much for all of your support. And as we mentioned, it's Patrons Day today, so thank you for being a patron. And if you want to join this growing community of people, then check out our page, patreon.com/iknowdino.
And jumping into the news, our first news story is a new dinosaur from Australia. It was published in JVP, and it was written by Steve Porapat, Matt White, Patricia Vickers-Rich, and Thomas Rich. And we spoke to three of them while we were in Australia. If you're familiar with any of those names, you could probably guess that this dinosaur is from Victoria. But interestingly, it's not an ornithopod, which is what we usually talk about from Victoria. It's a megaraptorid. And being a megaraptorid, that makes it sort of Allosaurus-like, I would say. If you're not familiar with megaraptorids, they have big hands, big claws on their hands. They're called megaraptors because they found the claw first, and they figured it must be a big toe claw, like on a huge raptor, thus megaraptor. But then later on, they figured out, oh, those are hand claws.
Yeah. And then they have fairly small teeth, at least smaller than you might expect.
Yeah, way smaller. We have a picture in an upcoming video. The megaraptor tooth is like the size of a fingernail, whereas obviously the T-Rex tooth is like the size of your forearm. So it definitely had a different eating style, more like the either chomp out bits sort of approach or the slash and wait for it to bleed out sort of move. It wasn't a big bone crushing T-Rex type, even though it was relatively big. You're talking about around 20 feet long. So pretty big dinosaur. You may be familiar with Australovenator, which is also a megaraptorid, and obviously from Australia. That's where the Austra part of Australovenator comes from, or Australovenator, as some people like to say.
Like everyone in Australia?
Not everyone. We found a person who says Australovenator.
True.
But this megaraptorid is about 12 million years older than Australovenator, and that makes it about 107 million years old. Most of the dinosaurs we talk about from Queensland are about 95 million years old. So that's where this 12 million year gap comes from. And since the divide between the early and late Cretaceous is like 100 million years ago, that means that technically Australovenator is from the late Cretaceous, while this new megaraptorid is from the early Cretaceous. And Australovenator is also 1,000 miles north in Queensland. This new megaraptorid is from the coast of Victoria, specifically Eric the Red West, and it's called that because it's west of the 19th century shipwreck of the American ship called Eric the Red. So there you go, Eric the Red West, west of Eric the Red ship. It's sometimes called ERTW, and that's the same place that Diluvicursor was found last year, or I should maybe say described last year. For this new Megaraptorid, they found several scattered bones, which they think are likely from the same species. They found 2 teeth, 2 claws, and an ankle bone, and they all look like Australovenator. So you might think, well, is it Australovenator? They're both from the same continent. They're both from the Cretaceous. But it's probably not Australovenator, at least not Australovenator wintonensis, which is the species that's been described so far, because species don't generally last 12 million years, and it's also 1,000 miles away and, passed over that boundary between the early and late Cretaceous too, which makes it even a little bit less likely that it would be the same species. It's possible that it could be another species of Australovenator or a closely related genus, so they could be like sister taxa in one way or another. More fossils would definitely help, but theropod fossils are very rare in Australia. And like I said, we basically just found a couple of teeth and claws that we're basing this on. So it's pretty hard to get a real diagnostic view of the dinosaur. And that's why I've been referring to it as the new Megaraptorid rather than a name, because they didn't give it a name. They basically used the Latin for it's a dinosaur like Australovenator wintonensis, which I appreciate because if they did give it a name, it's likely to become a nomen dubium or just get synonymized with something else or otherwise disappear in the near future and then be another dinosaur name that didn't go anywhere. Unfortunately, it's pretty unlikely that we're going to find a good individual of this theropod because theropod fossils are very rare in Australia. We do find a lot of sauropods in Queensland, and we find a lot of ornithopods in Victoria, but the Australovenator original was only found because of its proximity to a sauropod in Queensland. And like I said, this one was scattered all over the place, so it's not exactly an ideal find. But there were a few other bones in Eric the Red West that might be from the same species. There's a neck vertebra that was previously called a spinosaurid bone. So now we think it was probably a megaraptorid. There's a cervical rib, which is a neck bone that runs parallel to the neck. And that one actually includes a bite mark, which they're also thinking might be from this individual or from the species at least. There is a tail vertebra and also a finger bone that all seem like they might match up with this guy. So there's not that little known about it. Like we definitely have dinosaurs named from less than this, but still, especially considering how similar it is to a known species, it's probably not worth naming a new species yet out of this one. Interestingly, being from Victoria in the Cretaceous, it would have been a polar dinosaur.
That's fun.
Yeah, I think so. So immediately I checked to see what they had to say about whether or not it had feathers, but they didn't say anything, which is probably a good idea because they didn't find any feathers. And since this is a polar dinosaur version of a Megaraptorid, and then we also had the one up in Queensland, which I think would have been out of the Arctic Circle or Antarctic Circle at that point, is quite a bit farther north. It's interesting that both of these dinosaurs look so similar because it almost gives you the impression that Megaraptorids were roaming all over Australia in basically the same sort of body plan for over 10 million years. And we don't see any other really large theropods, so they could have been the apex predators of like the whole continent for all we know at this point. Or maybe there's just some other dinosaur that we haven't found yet. It also means that potentially these megaraptorids, like Australovenator, were eating sauropods in Queensland and ornithopods in Victoria, which are obviously very different sizes because ornithopods are like little dog-sized things, whereas, sauropods are huge. Maybe they were just scavenging sauropods and, actively hunting ornithopods or something. Up next is our paper about another Alaskan tracksite. This one was published in PLOS One by Anthony Fiorillo and others, and it's all about the Chignik Formation, which I hadn't heard of before. It's on the Alaskan Peninsula, so in the southwest of some of the recent discoveries we talked about in Alaska, sort of the beginning of that island chain that goes over to Russia. And this one's almost entirely hadrosaurids. Over 90% of the tracks are hadrosaurids. But in addition, they did find exactly 2 ankylosaur and avian tracks, and I think just like 1 non-avian theropod track.
What were those other tracks doing there anyway?
I don't know. They wanted to hang out with the hadrosaurids. Or maybe they were like picking bugs off the hadrosaurids or something.
The avians, not the ankylosaurs.
Yeah, that's a good point. I don't know what the ankylosaurs were doing there.
Or the theropods. I guess the theropods were looking for easy pickings.
Yes, maybe snacking on the hadrosaurs. And I think the most significant thing about this study is it's more evidence that hadrosaurs seem to really love beaches. We keep seeing this, especially hadrosaurids versus like the lambeosaurs that I guess were more up in the mountains, or at least just not right on the beach where they're making tracks all the time.
There we go. They're all on a beach holiday.
And speaking of non-avian theropods, we've got an article about T-Rex tooth replacement. At least that's ostensibly what it's about from the title, but really it's kind of a first description, at least that I've read, of Tristan the T.rex. So this one was published in Historical Biology by Franziska Sattler and Daniela Schwartz. And first off, I think it's kind of interesting. Tristan's full nickname is Tristan Otto. I didn't realize it was a two-part name. And that's because both Tristan and Otto are the sons of the owner.
That's nice.
Yeah. And it is still privately owned, but it's on loan to the Museum für Naturkunde in Berlin.
Oh, yeah. It's been on display, and then visitors could see them working on this.
Oh, I didn't remember that. That's cool. I think they said it's been there since like 2014 or 2015, so it's been a little while. And then eventually the plan is to move it to the Natural History Museum of Denmark, because I think that might be where the owner is. I'm not certain, but I think so. I'm actually kind of surprised, though, that researchers are publishing on Tristan because it is privately owned. And a lot of times journals won't publish on fossils that are privately owned, even if they are temporarily in a museum.
Maybe because they were researching in the public.
It could be. Yeah, and a lot of times universities won't publish on it either, but in this case it happened. So I don't know. But previously, T-Rex tooth replacements have been estimated about 2 years. And in order to estimate that, they used to cut into the jaws to find replacement teeth and then slice into the teeth themselves in order to do histology and count the lines to see exactly how many days old they think it is, because you can see the buildup of enamel slowly on like a daily basis. Using that, like I said, they think that it took about 2 years, which is on the longer side of dinosaur tooth replacement. It sounds really quick to us, getting a full new set of teeth every 2 years. But for dinosaurs, I think the fastest ones were like 20 to 30 days. They would get new teeth. I think that was some of the herbivores that really wore their teeth down.
It's a lot of chewing.
It is. And then some of the smaller theropods would replace their teeth about once every year or so. There's a lot of description of Tristan in this paper, but they did focus on the teeth. So there's a lot of detail, like, this tooth is this long and this percentage of it is exposed and all that kind of stuff. But just for fun, I think the most interesting one is probably the longest tooth, because everyone's always excited about the biggest things. The longest tooth in Tristan's skull is 28.2 centimeters long, or 11.1 inches, almost an entire foot. So that's including the root. And it looks like about 13.4 centimeters or 5.3 inches of it is functional. So like sticking up past the gum.
Still a lot.
Yeah, that is a massive tooth. They also found that the teeth were replaced in an alternating pattern by looking at the CT scan and seeing which teeth were most likely to be replaced next, based on basically the size of the replacement teeth. And that means that there would have never been a 2-tooth in a row gap. So there was always at least one mature tooth in every other position. So even though they were replacing constantly, they didn't have a really janky smile. Still okay.
That's important to dinosaurs. Their smiles.
Yeah. Well, it's important if you're trying to crush bone. Need some good teeth in there. Unfortunately, they couldn't estimate the replacement rate. They couldn't see the teeth equivalent of lags using CT scans. Usually you have to cut into the bone to do histology to get that level of detail. And I think the owner probably didn't want them doing destructive testing, which might be why people don't like to publish on privately owned fossils. Might be part of it. But even if it was in a museum collection, I'm not sure. Sometimes destructive testing is hard to get done anyway, because you don't necessarily want to damage rare fossils. But we might be seeing more papers come out about Tristan in the future, because this one mostly focused on the teeth and the skull.
Pretty cool. Last in the news, 3 baby Protoceratops that are housed at the Department of Geology at Southern Illinois Laboratory. They were found in 2017. They've been given names, well, nicknames, by 7th graders at a nearby school. So the university put out a contest, and then K through 12 students suggested names, and then the university students voted on them. So the names, and I'll do my best for pronunciation, are Sachi, Ido, and Ula, and they're on display with their mother, Nanu. And the name Nanu means beautiful, and Nanu was found in 2016. So Sachi means blessed child, Ido means work or labor, and Ula means powerful and prosperous. They're all Egyptian origin, like their mother's name, and their initials together spell out SIU, Southern Illinois Laboratory. So it all works out.
Isn't that clever?
It is.
And now on to our interview with Matthew Mossbrucker.
We are chatting today with Matthew Mossbrucker, who is the director and chief curator at the Morrison Natural History Museum in Colorado, and he's also on the board of the Glenrock Paleontological Museum in Glenrock, Wyoming. He studies the paleontology of the type section in Morrison, Colorado, of the Morrison Formation, and he also does digs in the Lance Formation, which has a lot of T.rex and Triceratops. Well, thanks for chatting with us today.
Hey, my pleasure. Thanks for being patient with me.
Of course, you've got a lot going on. I mean, 2 museums and plus many other things.
All the family stuff.
Yes.
It strikes me that those museums aren't really that close together, are they?
We are not. Not at all. Morrison is really, it's just on the edge of the suburbs in the Denver metro area. And then the Paleon is in the little town of Glenrock, a couple thousand people up there, and it is sandwiched between the towns of Casper and Douglas, Wyoming.
Oh yeah, that's a ways.
It's about a 4.5 hour drive. It just depends on how fast I'm able to go to get up there, but it's a good 4.5 hour drive.
You didn't want to get involved with another museum in Colorado? It's closer.
Well, when I came across the Paleon, I'd known of it for years, but they were struggling. And I thought that I could jump in and help with this joint field program. So there was a former mayor that didn't understand the need for a community museum that was actively trying to shut that place down.
Oh.
And we were able to show that it can bring in people and tourists to help out the local economy, lots of local media attention, and opinion changed.
Nice.
That's great. Can you tell us a little bit about that joint field program?
Yeah, the joint field program, it's a fun thing because what we're trying to do is take people out of the armchair that they're sitting in listening to podcasts. Yes, I am talking to you that's listening in your car or at home right now. I know you love dinosaurs, so do I, but I'm sure you want a deeper connection to natural history. So why don't you come out and join us, and we'll dig in the Lance Formation, home of Triceratops, duckbills like Dinosaurs, T.rex, and lots of other wonderful critters, from the tiny-toothed marsupial called Didelphodon. My crew collected a handful of teeth at our microvertebrate site this summer to shed Triceratops teeth in an estuary. So we're trying to map out where these dinosaurs were living and feeding. It's just a great amount of fun. So if you want to get dirty and sweaty and make a personal connection with paleontology, join us.
Nice. And so this is every summer?
This is every summer. And right now on our website, which is mnhm.org, you'll find our current schedule. So you can make some plans. We do have limited slots for the field program. So I would certainly suggest putting your hat in now.
Yeah. This is for any age? Or do you have to be a certain age at least to start?
Mentally, I would say you want to be, if you're a young person, fairly mature, ages around 10, 12, because it's really hot outside. Digging is not for the faint of heart. Mm-hmm. We do provide you with some shade, but it can be hot, and there's bugs and sharp rocks and cactus and rattlesnakes, and pretty sure there's still an Al-Qaeda enclave up there. But outside of that, 10 or 12 and up. And if you're an older person, just make sure that you can get around. If you're a younger person, also make sure you can get around, because I don't want to carry you. I've had to nearly carry people out in the past. So it's important that everybody is mobile and fit and healthy.
Yep.
It's nice that you provide shade. That's an uncommon occurrence for a paleontological dig.
Spared no expense. It's important for the comfort and focus of everyone to have a bit of shade. Yeah. When appropriate. Yeah.
Do you do that when you're digging without students and volunteers?
It depends on the nature of the site. If we know that we're going to be digging in for a while at a particular site that turns into a quarry that's producing a lot of material, large or small, we'll try to set up a shade canopy above it to keep the sun off of us, keep heat stroke at bay, and to just make us a little bit more comfortable in the hot Wyoming sun. But if we're out prospecting, looking at sites, measuring section, that sort of thing, shade is a luxury that eludes us.
So the Morrison Natural History Museum, that's a teaching museum.
Right.
Which is different, yeah.
Yeah, so basically, here's the story of our wonderful little museum. We started off in a recycled building without purpose. We had an old 1940s ranch-style cabin that was in the way of a highway project. And so it was moved to its current location, and a foundation was built below it. So we had a building before we had a foundation. Didn't have a purpose, but we had a retired palynologist, a fossil pollen expert, on our town board here in Morrison, who was keenly aware of Morrison's natural history, and he chose to make this into a natural history museum. The problem was, we didn't have a collection yet. There were a few fossil casts, kind of an eclectic small Western museum display for a number of years. And then in 1995, the museum was made a department of the town of Morrison, and it was able to write some grants and get some stable support to open up on a consistent basis. And we began refining the exhibits then. So it has an interesting backstory because most small museums start with some wonderful local discovery. The issue with the Morrison Museum is that the wonderful local discoveries that were made between 1877 and 1879 by Arthur Lakes, who had created and shipped all of Morrison's fossils out east to the Yale Peabody Museum of Natural History under the care of the famous Othniel Charles Marsh.
Mm-hmm.
So Yale was kind enough to loan back some material that was collected from Morrison at two of our sites, parts of the historic genoholotype of Stegosaurus armatus and part of the type sample of Apatosaurus ajax.
Nice.
And we reopened some of the historic quarries around the turn of the century. It's just fun to say that. And I found a lot more material too, including tracks and small vertebrate fossils, things that we are still working on today.
So those quarries, because we recently did an episode on the Bone Wars.
Mm-hmm.
Actually, I think I found a quote from you saying, like, people originally thought that Marsh and Cope destroyed as much as they could to keep the others from collecting, but then you and your team found that wasn't necessarily the case.
That's true at one specific site at the very least. It's important to remember that Marsh and Cope weren't doing the digging themselves through most of the Bone Wars. And yes, they were collecting earlier in their own careers themselves, but not later on, not by the time folks were digging in Colorado and in Wyoming. And the nature of our digs here in Morrison is that they're all located on a fairly steep ridge called a hogback. And they're very difficult to get to. There are four main historic quarries, and there's a couple of minor quarries that I found while going through the Yale Peabody Museum's basement, material that's still not accessioned into their collections. And of those sites, there is one main site that was the most productive, and it goes by three different names: Saurian number 10, Quarry 10, the Clay Saurian. It's all the same site. And thanks to Arthur Lake's wonderful field notes, a wonderful watercolor sketch, and the rock and the fossils themselves, we were able to relocate this particular dig site and dig in. And when I began digging in, I realized that this site it was a soft, almost black, kind of a charcoal gray mudstone. I was excavating underneath a sandstone ledge, so it's a much harder rock than that mudstone, trying to get in to find where this mud rock was to see if there was any material left. And I had found that the dirt over the years since 1879, when the quarry was closed, was stratified top to bottom, thin sheets, not consistent with the blast that supposedly closed the quarry. So, yeah, I mean, the Lakes was told by Marsh to blow the thing up, but he didn't. He didn't. And I appreciate that. I do. I deeply appreciate that.
Yeah. A lot of people appreciate that, I'm sure.
I think we all do. Yeah. we should not go around blowing up dig sites. I think that is not something we should engage in.
Yeah. Yeah, just using explosives in general when you're dealing with fragile fossils is not recommended.
I think it's probably a bad idea. I don't want to have a strong opinion because I don't like to be wrong, but probably not.
So the Morrison Museum, you do a lot of daily tours 3 times a day, and it says on the website it's customized to what you're interested in learning. So how does that work?
Well, here's how this works. Because, unfortunately, we've noticed over the years at our museums and others that folks don't always read the labels. And when they're not reading the labels, that interpretation isn't getting across to them. Being a small museum with budgetary limitations, bringing in technology was challenging in the early days, like even audio tapes to have an audio tour of the museum or something of that nature. We decided early on that it was most effective for us to show people around, to talk to them about the fossils, ask them questions about what they already knew, surprise them with some of the local information, and try to make connections through life history and the people that were standing around these fossils. And it was really successful. We got great feedback. And it was, even in the early days when we did not have much to see, that was the most successful program that we had here. The museum has grown substantially in our collections, and we've certainly refined our programs. But when you come in to the museum and check in, we just show you around, give you an informal tour. We try to organize people to come in thrice daily. It doesn't work. But I have a large enough staff and group of volunteers now so that allows us to show everyone around that comes through. And it's a great time. People walk away with a much deeper knowledge and appreciation for Morrison paleontology than they came into the museum with.
How far outside of Denver are you?
Oh, I can actually see the airport from my office window out on the horizon line and the skyscrapers of downtown. We're just a few minutes outside of Denver, I think 20 minutes if you drive slow.
You found the first baby Stegosaurus fossils. Where did you find those?
In my parking lot.
Really?
That's not a joke. Here's how this happened. About a decade ago, there were loose sandstone boulders, all full of fossils, on the side of a local road. This road, which we've nicknamed Dinosaur Ridge over the past, 3 decades, is an important site historically because on the west side of the ridge, there is a historic dinosaur dig quarry called the Quarry Number 5. And at Quarry 5, that's where the historic genoholotype of Stegosaurus was collected. And we knew that these sandstone boulders serving as a guardrail on the side of this road were from Quarry 5. So at the 11th hour before a roadside construction project, my crew came in and we moved all of these big boulders back to our museum for safekeeping. These boulders turned out to be more fossiliferous than we could have imagined, because not just bones were contained in these boulders, but there were also fossil footprints, tracks in these blocks as well. So we began to carefully extract the bones from the boulders and the tracks, if we could, from the blocks. And we just ended up moving some of the boulders inside the museum for preservation. because one of the first blocks that we had stumbled across, this is found by our Dr. Bob Bacher. He's a bearded paleontologist. You may have heard of him.
I like describing him as a bearded paleontologist.
Well, let me be more specific. He's a bearded white paleontologist. That doesn't really narrow it down at all, does it?
It's like 90% of paleontologists.
I know it's unfortunate. That is changing, but that's I like to tease him about that. As a bearded white guy myself, who am I to talk? So we moved this boulder inside the museum, and after a little bit of preparation separating the mudstone that had filled in these footprints, we had found that we were looking at the best example of Stegosaurus tracks in the world. For the first time, we had a complete couplet, or a hind foot and forefoot print of the same individual.
Nice.
And the handprint is so detailed, you can make out the distinction between pads and claws in that track. It's a wonderful footprint. And we also caught an embarrassing moment in that dinosaur's life because the heel of the hind paw is exaggerated. The animal, when its tiny back paw hit the wet river sand, it slid forward. And as luck would have it, we have juvenile tracks, a half-grown stegosaur tracks on that same block. So that inspired us to look at the other loose quarry-five boulders that we had collected. And lo and behold, there were more tracks belonging to Stegosaurus. Now, the obvious question is, hey, bearded white guy, how do you know that these are Stegosaurus tracks? Because I've read that most dinosaur footprints are really hard to assign to a specific dinosaur. And I would say this. I would say, well, Stegosaurus hind paws are unique. They do have 3 toes. The toes are very short. They're very thick. And most importantly, the claws are squared off, almost hoof-like. So especially the middle toe. The 2 lateral toes are also beveled as well. And depending upon Stegosaurus versus Hesperosaurus, the bevel's at a different angle. So you can tell Stegosaurus hindpaw tracks from Hesperosaurus hindpaw tracks.
Wow.
So moving forward, just by simple shape matching, when we started seeing smaller and smaller tracks, we realized that we were sampling this wonderful Morrison Jurassic ecosystem that didn't just have dead adult stegosaurs, which Arthur Lakes had found in 1877, but the dinosaurs were being born here. And guess how many Stegosaurus eggs or nests we found in the world since the time of Arthur Lakes? Just guess.
2.
Subtract 2.
Oh.
Not a single one. So the presence of these tiny tracks, the smallest track you can cover up with a 50-cent piece. The animal would have been the size of roughly an American football and could have curled up and slept in the hindpaw track of its mom or dad.
Oh,
Just like Land Before Time.
that's cute.
Just like Land Before Time. So that was really fun because now we have this growth series of tracks. It's a very small sample, but a significant one because juvenile Stegosaurus remains are super rare. And people don't appreciate dinosaur feet in general, I'm afraid, let alone Stegosaurus feet. But they're quite fascinating.
I'm surprised, since you can tell a Stegosaurus track. Why wouldn't people be more interested?
I don't know. When it comes to trying to put these animals into context, the environments that they lived in, which is what we do in our programming here at the museum, we try to get, past the teeth and into the brain case of the dinosaur, thinking about what the animal would have seen when it was here at various points in Earth history. So if you're a Stegosaurus living here in Morrison at the end of the Jurassic, and you were to look around, there would not have been a lot of topographic relief. No mountains in Colorado, so apparently the skiing was terrible. And Denver's nickname is the Mile High City, but back in the Jurassic, we were more or less the sea level city, fairly flat, maybe a few rolling hills. We have a few fossil lakes in the Morrison Formation here in town, but they're very small. And the streams themselves, too, are small as well. Looking at the floodplains adjacent to the streams, they're pretty well drained. These are the surfaces that the dinosaurs would have been active on. So that the soil seems to indicate that it would get wet for a time and then dry out. What's really interesting, probing into the soil, we don't find a lot of evidence of roots driving into the soil. Fossil plants are extremely rare here in Morrison. That's due more to the geochemistry, I think, being more alkaline, not conducive to producing fossils of plants. But there's really not a great indication of a ton of plant life here in Jurassic Morrison. So if you're a Stegosaurus and you're looking around fairly flat, not a lot of plants. Most of our knowledge of Morrison Formation plant life comes from sites that were wet and swampy, that were not here in Morrison. So we really can't even think of the Morrison Formation as this homogeneous plane of the same landscape and the same fauna and the same flora everywhere. It doesn't work like that. So trying to get people to think and envision what these habitats were like through time, comparing them to what we've been exposed to through pop culture, whether it be dinosaur books like I was, or movies like there's that movie about that park that everything went. What was that? Jurassic Park.
That small little indie film.
That little indie film came out like 25 years ago. Taking these cultural touchstones that people have and meeting them somewhere in the middle, taking what they know or what they've been exposed to, which is that dinosaurs were alive and they were here, and then trying to deepen their knowledge and their appreciation for these ecosystems through time that would rise and fall over and over again for 170 million years when it comes to dinosaurs. And we have a pretty good record, certainly not a complete record by any stretch of the means, of more Mesozoic paleontology here in the Front Range of Colorado. But it's just such a fun challenge trying to introduce real history to the general public.
Yeah. So I'm trying to imagine like a modern analog for the Morrison. Is it kind of like the Dakotas, but the non-mountainous part of the Dakotas?
Kind of think of it more like the Australian outback.
Oh, wow. That barren.
Yeah. Not a lot of ground cover. I mean, just probing into the soils, whether we're looking for an organic horizon on top of the paleosols, like you would see in a tropical soil. It's not there here when we're digging in our Jurassic rocks. Looking for root casts, large and small. They're not there. So far as we have found, we've sampled everything fairly extensively. It's just all fossil pollens. Haven't found much, although that really is an area of future research I would like to exploit, looking for more fossil pollens. But areas in which fossil pollens would concentrate, we don't have many of those exposed on our ridge, unfortunately. So when it's all said and done, the indication is that there's not a lot of plant life growing here.
That's surprising with all the herbivores that are in the Morrison Formation.
It is, especially right here, because the most abundant herbivores are Apatosaurus ajax.
Yeah.
Right. So we have from Quarry 10, Lakes collected a partial femur, and when reconstructed, that femur would be about 2,030 millimeters, so 6 feet 6 inches tall.
Nice.
This is a big dinosaur, Apatosaurus ajax. This is a mature beast. The type specimen of Ajax, YPM 1860, is a young critter. 3 sacral vertebrae, had a lot of growing to do. It's still a big dinosaur, but it's not as big as the other animal buried at the same site. We have Apatosaurus occurring at other sites too, and only within the past decade have we started finding remains of Camarasaurus here. No Diplodocus yet, or Diplodocus, or Diplodocus. I want to please all regional variations of the pronunciation of the double beam. So the question is, okay, what are these dinosaurs, these giant multi-ton dinosaurs, feeding upon here if we don't have a lot of plant life? Well, how do we know where dinosaurs were feeding in general? Well, we look for specific clues, those clues being shed tooth crowns. Mm-hmm. Dinosaurs that had teeth have a wonderful dental plan. Paid extra for this. They had a never-ending supply of teeth in their jaws, so they can lose teeth and regrow them throughout their lives. And a shed tooth versus a live tooth, it's easy to spot the differences. Shed teeth are usually very worn at the apex of the crown, so the end of the tooth making contact with whatever the dinosaur is eating. But the root of the tooth dissolves within the jaws. Mm-hmm. And the only thing that's left in the jaws is just the crown, the part of the tooth that you see sticking up above the gum line, held in there by the periodontal ligament. So the next time that dinosaur bites into something hard, that tooth snaps out. Mm-hmm. So here's a specific example. Lakes at Quarry 10, Arthur Lakes, Quarry 10. This is 1878. Whilst digging up the first Apatosaurus, he found a half dozen small carnivorous dinosaur teeth.
Oh, wow.
And even though they hadn't been cataloged at the Peabody, he did diligently map them into the quarry. And I have copies of those. I know where they were found exactly in relationship to the bones. And when I went through shelf by shelf, looking at all of the stuff that Lakes had dug up, here and there I would find, oh, there's an allosaur tooth. And it's really worn. The serrations are worn off. The tip is worn, and there's no root attached. So that's a shed tooth. So right there we can reconstruct some Jurassic ecology, this food web that Allosaurus was chewing upon the carcass of this giant Apatosaurus ajax. We can't tell whether or not the Allosaur was scavenging or had preyed upon that Apatosaurus, but we can discern this energy flow, this food web of one animal consuming another. Mm-hmm. And that's interesting information that goes back 145.5 million years. But when it comes to herbivorous dinosaurs, I've seen from our sites here in Morrison multiple teeth belonging to long-necked dinosaurs, specifically camarasaurs and diplodocids, so animals like Apatosaurus or Diplodocus. Mm-hmm. And they all have roots. They're all more or less unworn. There's no evidence that these teeth were shed. And that's not uncommon. So when we look at other sites in the Morrison Formation, shed herbivorous teeth that are mapped in and documented that go into museum collections are not abundant. Unfortunately, we don't have any evidence that our giant mega herbivore population was resident. We have no evidence that they were feeding here. Maybe just stopping through and then moving on. So I think that there's your answer. Our resident population of Apatosaurus ajax wasn't resident at all. They were snowbirds. They were passing through in this Jurassic highway.
You've spoken a little bit or written a little bit about Brontosaurus and Apatosaurus. Do you want to tell us what you think about that?
Here's what I think. This is going to be painful to hear. Because we dino geeks, we always want to be right. And when I was growing up, I would take information from my dinosaur books and regurgitate it. And one of my favorite phrases, to be a little Jurassic smarty pants, was to say, actually, it always has to start with actually.
Yep. It does.
Actually, Brontosaurus doesn't exist. It's actually Apatosaurus. Adults would say, well, I love Brontosaurus. I'm like, well, I'm sorry. It never existed. And I could not have been more wrong. After laying my hands on the first Brontosaurus remains and part of that type sample from, it's called Quarry 10 up at Como Bluff, Wyoming, and our local Morrison sample, and looking at other Apatosaurs spread out through the Morrison Formation, they are reflective of unique anatomical features in the skulls and in the necks, and to a lesser degree to the chests. Now, the reason why Brontosaurus and Apatosaurus were synonymized in the first place was because of a true error that was pointed out by Elmer Riggs in 1903, in that as sauropods, these long-necked dinosaurs, would grow, the three bones that make up the sacrum, so this is kind of the block of vertebrae in between the big blades of the pelvis, the ilia. As these animals mature and they kind of accession weight into their rumps, they would have loose sacral vertebrae, both before the sacrum and after the sacrum, fused together to strengthen that unit as a singular unit. And Elmer Riggs pointed that out. He also pointed out the similarities and the shoulder blades of the dinosaurs too, just based upon Marsh's publications, because he didn't, I don't think he ever got the chance to view these specimens personally. He was going off of the work that had been published prior to him. Now, he was right. He pointed out a real issue. And because he saw so many similarities in other regions of the body, like the shoulders, and that the rationale that Professor Marsh had used to separate Apatosaurus from Brontosaurus, which was the number of vertebrae in the hips, the first specimen of Apatosaurus had 3 vertebrae in the sacrum, and the type specimen of Brontosaurus excelsus had 5 vertebrae. That basis was recognized as growth through time, ontogeny, right? Mm-hmm. And that paper was more or less ignored, unfortunately, because that was some solid work up until Jack McIntosh and John Berman pointed out in the late 1970s that, well, we've been putting the wrong head on Brontosaurus and Apatosaurus all this time. Oh, and by the way, back in 1903, Elmer Riggs synonymized Brontosaurus looked pretty similar in certain regions of the body. The fun thing about paleontology is, being the data-driven science that it is, if we want more data to refine our understanding of these wonderful critters, we need to go out and dig and collect more and more, which has been occurring since the time of Arthur Lakes here in the American West. And our sample size and our understanding of these animals has grown exponentially since then. And both Emmanuel Schaap and his colleagues pointed out some differences in the skeletons of both Brontosaurus and Apatosaurus. And the work that I'm actually doing right now is going to show some substantial differences in both the skull and in the neck of both Brontosaurus and Apatosaurus too.
Cool.
So the tiny dino geek in me from the 1980s, who walked around with such authority, telling people that Brontosaurus didn't exist, I am now offering my penance. I am wrong. It's legit. It's a real thing.
Yeah.
Can you tell us a little bit about the work you're doing with that now, or is it too soon to say?
It's a little soon to say because the specimen that we're working on is a partial skull that's in a very hard sandstone. And when I say it's a hard sandstone, these grains of quartz are interlocking with one another like 3D Tetris tiles, and trying to tease them apart without damaging the more brittle bone is very difficult. Requires a lot of time and specialized tools. We've tried scanning the blocks. We have no resolution because it just reads as one giant lump of glass. So we have to go through with very specialized fine mechanical tools to break apart the sand grains a little bit at a time. So it's doable. It just is taking a lot longer than we would have hoped.
Sure. But
yeah,
it looks like you've done some work in this area already, because you co-authored a conference paper about how Brontosaurus and Apatosaurus had a different head mechanics.
They did, yeah. Yeah, Bob and I recognized after my first couple trips back to the Peabody that the Brontosaurus skull that he and his crew collected near Como Bluff, Wyoming in the mid-1990s, the brain case of that animal was wildly different than the brain case of Apatosaurus ajax. That these animals, the muscle attachments below the main attachment point from the head to the neck, suggests that the neutral position of the head of an Apatosaurus versus a Brontosaurus was very different by like 90 degrees.
Oh, wow.
So, I mean, even from a distance, if you were to see a silhouette of an Apatosaurus or Brontosaurus, you'd be able to pick it out. if they did indeed live at the exact same time in the Jurassic, which I'm not convinced of because we haven't found Excelsus remains with Ajax remains yet. Still something that we are probing into in our big Apatosaurus Brontosaurus paper.
Cool.
I look forward to reading that.
Me too. I look forward to finishing it so that I get that monkey off my back.
Sabrina's favorite dinosaur is Brontosaurus, and then she had to, for a while, say that it was Apatosaurus, but now she's back to saying it's Brontosaurus again.
Well, it truly is. And in fact, even saying that they were the same dinosaur, which you've probably uttered that same phrase too.
Mm-hmm.
Historically, it was never argued that they were the same species or the same dinosaur. So they really aren't the same dinosaur. They are very different. In fact, looking at the head neck mechanics of Bronto versus Apato, they're more different than modern day cervids, elk, deer, and moose. I mean, elk, deer, and moose neck vertebrae all look more or less the same. They just get more robust as the animals get larger. Apatosaurus and Brontosaurus, the cervical ribs are different shaped. The necks are of a different geometry and cross section. Apatosaurus is wider than Brontosaurus, allowing the neck to move left, right differently from one animal to the other. They're very different beasts. They really are.
Yeah, it's one of those problems with how everybody just knows dinosaurs by the genus name alone. And then so if there's a subspecies,
right,
or not even a subspecies, just more than one species in the genus, no one knows how to talk about it because nobody ever uses the species names.
Right. And then when you have the taxonomic lawyering going on, where some people want to take juvenile animals and make them adult animals, or vice versa, or not try to put animals in context of time and space, just for the sake of keeping it easy, because defining a fossil genus can be subjective based upon the worker. And a lot of cladistic analysis, which sounds very scientific, it's easy to skew the results, or just say the computer spat this out and it's what it says. So this is what we're going with for our taxonomy, regardless of how morphologically distinct animal A is from animal B.
Yeah,
we tend to use special plea arguments of ontogeny or sexual dimorphism or individual variation. We can't quantify those three things with our Morrison Formation sample, except for maybe, say, Cleveland Lloyd with the Allosaur sample there, Quarry 13, maybe. But ontogeny is not terribly hard to quantify, but individual variation, sexual dimorphism, dude, with a sample size of 2, you don't know what you're doing.
That's for sure.
So for our listeners, if they wanted to find out more about you and your work, where's the best place for them to go online?
If you guys really want to learn more about what we're doing and what I'm doing, most of my work's posted on the Morrison Museum Facebook page.
Nice.
There's usually links to things that I've done, whether it's the T-Rex autopsy that I did a few years ago for National Geographic, all the way up to little academic papers.
Great. Well, thank you so much for joining us, and hopefully one day we'll make it out to the Morrison Museum.
Oh yeah, it's on our list.
Well, Garrett and Sabrina, it's been a pleasure chatting with you. I know I tend to ramble, but I get excited about this stuff, and
we do too.
It's hard to contain me. So that's cool. I hope to chat with you guys again, and come on out to Morrison. I'll show you around.
Great, thanks.
Thanks again, Matthew, for chatting with us. One day we will make it out to the Morrison Natural History Museum. We're really excited about it.
Yeah, Denver is definitely on the list, the short list of cities we need to make it to, because it's close and there's so many good museums there.
Yep, and then Morrison's not far from Denver.
Yeah. And before we get into our dinosaur of the day, a quick reminder that our book is waiting to be added to your holiday wish list. I know wish lists sometimes get out of date, and then you've got a bunch of old stuff on there you don't really want anymore. So take a look at it.
Yeah, this book is new.
It's brand new. It's got new dinosaurs in it that aren't really in any other books. And you can get 50 little vignettes about details that we know about their lives, because there's usually at least something interesting you can tell from a fossil. And Sabrina managed to weave all these little elements into 50 stories.
Yeah, so it covers 50 stories from dinosaurs discovered in the past 5 years, and then also facts about other dinosaurs, because there were over 100 dinosaurs discovered in the last few years alone. So if you are looking for something to add to your wish list, or you know a dinosaur enthusiast in your life who you need to buy a present for, then this could be a good gift. And a quick, easy link to get to it is bit.ly/50 dinosaur tales. That's the number 50 and then tales, Tales. And now into our dinosaur of the day, Leptoceratops, which was a request from Dinosaur 4602. So thanks. It was a ceratopsian that lived in the Late Cretaceous in what is now Western North America in Alberta, Canada, and Wyoming in the US. Leptoceratops is estimated to be about 6.6 feet or 2 meters long and weigh 150 to 441 pounds or 68 to 200 kilograms. It's quite a range. And it's both quadrupedal and bipedal. It could probably stand and run on 2 legs, and it could walk on 4 legs, though it couldn't pronate its hands. A 2007 study found Leptoceratops kept its hands in a clapping pose.
So in other words, the fingers are pointed out to the sides, not up towards its head, like when babies crawl.
Yep. Leptoceratops had short, downward pointing horns near the cheeks. It also had a frill and a leaf-shaped tail. It was herbivorous, and it had these short, deep jaws and a powerful bite, so it could shear and crush plant matter, and is probably able to chew pretty tough vegetation. Leptoceratops was probably a low browser, eating ferns and conifers. There's one study in 2016 by Frank Variel, published in PeerJ, that found the dental microwear on Leptoceratops' teeth was similar to some rodents, and Leptoceratops is, quote, the first evidence of complex mammal-like chewing in a ceratopsian dinosaur. The type species is Leptoceratops gracilis, and the genus name means little horned face. It was found in 1910 by Barnum Brown in the Red Deer Valley in Alberta, Canada. There wasn't a skull found at first, but then later more fossils were found by Charles Sternberg in 1947, Charles M. Sternberg, the son, and more fossils were found in the Bighorn Basin in Wyoming in 1978, and that one's nicknamed Lance. Brown found 2 skeletons, but they were on a cattle pathway, and the cows trampled the exposed fossils. And then Brown described Leptoceratops in 1914. Some fossils were found in Montana in 1942, and they were called Leptoceratops cerarancos, but then later that was renamed to Montanaceratops. In 2003, a lower arm bone, the single ulna, was found in Australia, and Patricia and Thomas Rich found that it looked similar to Leptoceratops, so they named it the Ceratopsian Serendipiceratops. But some scientists think that there's not enough known about this one, but if it is related to Leptoceratops, it could change what we know about Ceratopsian evolution, because there's no other Ceratopsians found in Australia. Those Australian dinosaurs, they keep coming up.
Mm-hmm.
And if you have a chance, you can see Leptoceratops at the Canadian Museum of Nature in Ottawa.
And our fun fact of the day is that dinosaurs have been in space at least twice, not including any bits that have been launched out of the atmosphere during the Chicxulub impact. So in 1985, some Maiasaura bone fragments and eggshell fragments were taken up to Space Lab 2. As far as I can tell, they weren't used in any actual experiments on the space station, and it was just a publicity stunt. But that's probably a good thing, because prepping fossils in space would be a really terrible idea. All of the fine rock debris would cause a lot of havoc in zero-G. There's all this stuff they do to try to eliminate powders and, fine rock type stuff from being in the air, where it, can get in your lungs or jam and clog up equipment or cause all sorts of other problems. So yeah, space is not a good place for paleontology preparation work. I thought maybe they were trying to do something with like a chemical analysis or something, but apparently it's not anywhere in their notes about experiments that they did. So I guess they just took it up to say that they took a dinosaur into space. And then again, 13 years later, in 1998, a Coelophysis skull was brought along on a mission to Mir. And again, I think that was just a publicity stunt. I couldn't find any justification for it anywhere. But considering piloted spaceships explode more than 1% of the time,
Yikes.
Yeah, I think it's probably good that we haven't launched any other dinosaurs in the last 20 years, because what's the point in taking something irreplaceable into space just to say you took it there? It's like, it doesn't make a lot of sense. It's the same reason we don't launch nuclear waste into space, because there's a chance it could blow up and then you have nuclear waste going everywhere. So let's just leave the dinosaurs on Earth. They're perfectly fine here.
And on that note, that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe so you don't miss out on any new episodes. And if you want to join our growing community of awesome dinosaur enthusiasts, check out our page, patreon.com/iknowdino. Thanks again. Until next time.